Good day, students. Welcome. Today we will going to discuss the topic 6 of this course, which entitles the methods of measuring stream flow and discharge calculations. So this will be for the authors and contributors of these materials, and here is for the copyright notice. For the intended learning outcomes, after this lecture and exercises, you, the student, must have: first, describe the different methods of measuring stream flow in natural and artificial channels. Second is to know the uses of a flow meter. Next is to memorize formulas to determine the stream flows and discharge. And lastly is to perform computations to determine stream flows and discharge. For the outline of the presentation, there are two parts that we will going to discuss in this material. The part 1 will be the velocity area method, and for the part 2 is the slope area method. Alright, so let's start for the part 1, which is the velocity area method. But before that, so let's have an overview on the measurement of a stream discharge. So a stream discharge is usually made in connection with the design of the water supply systems. Also for the flood protection works, or kanang mga flood walls, no? And hydroelectric power development, irrigation systems, and fishing farm structures. It is really need to determine the data for the stream discharge for us to know the specific structures that are we going to establish in the specific location. For example, for flood protection works, so we need to determine the discharge of the water in that water bodies, specific water bodies, for us to determine kung unsa ka lig-unon ang ato ang structure nga ito po diha. Also for the hydroelectric power development, so we need to know the discharge of the specific outlet para mahibaw na to kung pila discharge sa isa ka water nga makatuyok sa dynamo para maka-create og electric or electricity. Also for irrigation systems, also dapat na ito mahibawan sa ang data sa pagkuha sa discharge sa specific stream is essential for the designing the irrigation system. And in connection, the construction of the bridge, so system discharge daw ko is needed in order to position the structure safely above flood levels. So masabtan naman siya pag bridge, of course we need to determine the discharge of the specific stream or river. Also, it is important to determine the maximum discharge of the stream when estimating size of culverts and waterways areas. Kanang pag drain sa mga tubig from one place to another place, dami nagmutabok siya o bridge or canals. So, pag moagi siya kalsada, so para ma-estimate na to kung unsa kadako ng culvert or box culvert nga itong gamiton to drain the water from the other side, is we need to determine first what is the maximum discharge nga pwede nato butang, okay, kung once ma-determine nato ang discharge, ma-determine na pod nato kung unsa kadako ng size sa culvert. Out from that, of course, itong atong take into consideration kung kani kadako ang maximum discharge nga makater ani nga culvert, pila po ang time na ma-drain ang tubig from one location to another location. So the first method for this material is the velocity area method. So this velocity area method is commonly employed in channels and rivers. So kaning method, and it is essentially making observations of velocity at selected depths on several verticals or subsections along a line transverse to the direction of the flow. So, mo ni inyong gibuhat sa inyong second laboratory exercise tong floats, and katong nagbuhat mo verticals kay para dito what do you call this one, i-deploy ang float, so ang katong mga intervals, so kung ato siyang i-relate for this method, velocity area method, at that point makuha mo og sounding. So when we say sounding, makuha mo og depth at that specific interval, So ato na i-visualize later. And the result is quite accurate since the cross-section of the entire flowing body of the water is divided into several smaller subsections. Then, the velocity of each subsections is determined separately, no? And multiplied by its area, and the sum of these products gives a total discharge of the whole cross-sections. So, yung nang iyahang concept, no? For example, this is the cross-section sa isa ka river or water bodies. So, nagbuhat mo dira og range lines which is perpendicular to the flow of the water. And mo ni imong interval 1, 2, 3, 4, 5, no? Same sa gibuhat niya sa katong pag-interval sa float, no? And this specific interval, kuhaan niyo siya kung unsay kalawomon dira nga part at that instant. So as a interval 2, 3, 4, and 5, no? And then also, di ba nag-release mo diri og float, no? So for example, float inyong gigamit to determine the velocity of the water. So di ba nag-release mo diri og float diri. So mo ni ang velocity at this specific point, no? So another na pod nag-release na pod og float at this specific point, and so on and so forth. So nanamoy depth o nanamoy velocity at this specific interval. So ang area ani niya kani nga part, so this is the cross-sectional area of this part, then another na pod cross-sectional area for this part, cross-sectional area for this part, and so on and so forth. Then ang velocity nga atong i-times or ato ang multiply for the cross-sectional area is the velocity at the middle of the interval. So, kung saan mo napagkuha sa velocity, so ato lang tong i-mean ang velocity sa katong vertical. So, natay velocity diri, di ba, ka nag-release tag float, tapos napagtay velocity diri, ka nag-release ng tag float, ato lang kuhaon ang iyang mean, mo na ang iyahang mean velocity at this specific cross-sectional area. And to determine the discharge is, we're going to use the formula that Q is equals to A times V, or discharge is equals to area times velocity. So this will be the equations, no, sa inyong mechanics, I think, no, sa hydraulics nga part. Discharge is equals to area times velocity. Area A is the cross-sectional area and V is the mean velocity. So let's have a sample problem, no? So the right and left water edges of a stream are 3 meters and 32 meters respectively from an initial reference point. So therefore, ang pasabot ani niya is na daw ko na initial point, and ang right water edge niya is 3 meters from that initial point, and the other one is 32 meters from the initial point, which is the left water edge. So verticals, or ang ato ang term is intervals, no, are located at distances 5.5, 8.5, 11.5, 14.5, 17.5, 20.5, 23.5, 26.5, and 29.5 meters from that reference point. So, ang depth daw kun of the verticals are 0.6, 1.2, 1.4, 2.4, 2.6, 2.7, 2.5, 2.0, and 0.9 meters. Again, this is from the right water edge. And we have also mean velocities in that specific verticals or katong intervals. So, these are 0.2, 0.5, 0.7, 0.9, 0.9, 1.0, 1.1, 0.6, and 0.2 meter per seconds respectively. So, ang katong na ay depth sa verticals, naapod to siya specific mean velocities. Assuming that the discharge in the end sections of the stream to be 0, determine the following. First, cross-sectional area of the stream in square meter. B is the discharge of the stream in cubic meters per second. And the average velocity of flow of the stream in cubic meter per second. So let's visualize the given problem. So again, this is the reference point, and this is the starting or the left water edge, right water edge rather, and this is the left water edge. So from the reference point, this is 3.0, 5.5, 8.5, 11.5, 14.5, 17.5, 20.5, 23.5, 26.5, 29.5, and 32. And if you're going to subtract, no, the like for example, no, 8.5 to 5.5, so we have these distances of the verticals. So we have 3.0 from the starting to the left water edge, right water edge rather. Then first interval is 2.5, then 3, 3, 3, 3, and for the last part, last interval going to the right water edge, left water edge rather, is 2.5 meters. And we have depth of 0.6, 1.2, 1.4, 2.4, 2.6, 2.7, 2.5, 2.0, and 0.5. And we have also specific velocities. So again, this is stated in the problem na wala siya velocity, no, at this specific na point, because this is the point where we located the right water edge, and this is for the left water edge. So we have velocities 0.2, 0.5, 0.7, 0.9, 0.9, 1.0, 1.1, 0.6, 0.2 respectively. To solve, let us first solve the cross-sectional area. So we're going to assume or to rename vertical 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 verticals. And we have also, in that specific vertical, we have a specific velocity and specific depth. So let us first solve for the cross-sectional area for verticals 1 and 2. So to assume the area of this specific verticals, we're going to use the formula for area of the triangle. So we have 1/2 times 0.6 times 2.5, which results into 0.75 square meter. Next is the area for the verticals 2 and 3. So in this part, we are going to use the formula for trapezoid for estimating the area of this one. So we have 1/2 times first vertical 0.6 plus second vertical 1.2 times the distance between the verticals, which is 3.0. This results into 2.7 square meter. Another for cross-sectional area for vertical 3 to 4, we have 1/2 times 1.2 plus 1.4 times 3.0. This results into 3.9 square meter. Another one for area 4 to 5, same formula, 1/2 times the quantity of 1.4 plus 2.4 times distance 3 is equal to 5.7 square meter. Another for area 5 to 6, same formula, 1/2 times 2.4 plus 2.6 times the distance 3.0, that results to 7.5 square meter. For area 6 to 7, same formula will apply, 1/2 times the quantity of 2.6 plus 2.7 times the distance 3.0, which results into 7.95 square meter. Area 7 to 8, or area of the verticals between 7 to 8. Same formula applies, 1/2 times 2.7 plus 2.5 times the distance 3.0. That is equal to 7.8 square meter. Area of cross-sectional area between 8 to 9 verticals. 1/2 times 2.5 plus 2.0 times the distance 3.0. That results into 6.75 square meters. And for the area of the verticals between 9 to 10, same formula, 1/2 times 2.0 plus 0.9 times 3.0. That's result to 4.35 square meters. And lastly, we have the area of the verticals 10 to 11. No? So we have 1/2, no? Since this is triangle, no? This is triangle. So we're going to use the formula for triangle. 1/2 times 0.9 times 2.5, that results into 1.125 square meter. And to determine the cross-sectional area of this whole stream or a river, so it's simply we're going to get the summation of all the areas of the between the verticals. So if we're going to get those area or the area of the whole stream or the cross-sectional of the stream at this specific range line, so ato na siyang isum tanan, and to get the sum, so it results to 48.525 square meters. So this is now the answer for letter A question. So next is we're going to solve for velocity. Anong kinahanglan pa nato siya kuha velocity, sir? Nga naman siya velocity nga kaning 0.2, 0.5, and so on and so forth. So take note, as what I have discussed earlier, the velocity that we are going to use is not the velocity in the verticals. We need to get the velocity in the middle, in this part, in the middle sa duha ka verticals or duha ka intervals. So to get that average velocity is we need to get the average of two successive velocities. For example, velocities for vertical 1 to 2. So we need to have a average. For example, 0 in vertical 1, so wala man siya velocity, so 0 siya. So 0 plus 0.2 divided by 2, or 1/2 times 0 plus 0.2, it results to 0.1 meter per second. Another one for velocity in the verticals 2 to 3, same formula applies. 1/2 times the quantity of 0.2 plus 0.5, that is equal to 0.35 meters per second. Next is for the velocity between 3 and 4. So we need to get this the mean, so 1/2 times 0.5 plus 0.7, that leads to 0.6 meters. For velocity between 4 and 5 intervals, so we have 1/2 times 0.7 plus 0.9, that is equal to 0.8. Verticals between 5 to 6, verticals rather. So we have 1/2 times 0.9 plus 0.9, so that's lead to 0.9 meter per second. For velocity 6 to 7, we have 0.9 plus 1 divided by 2, which is equal to 0.95 meter per second. Velocity in the interval 7 to 8, so 1/2 times 1.0 plus 1.1, that leads to 1.05 meter per second. And for velocity 8 to 9, we have 1/2 times 1.1 plus 0.6, that is equal to 0.85 meter per second. In the velocity for interval 9 to 10, we have 0.6 plus 0.2 divided by 2, that is equal to 0.4 meter per second. And lastly, for intervals 10 to 11, we have 1/2 times 0.2 plus 0, that leads to 0.1 meter per second. And to solve for the discharge, we are going to use this formula. Discharge is equals to area times the velocity. So we have now the area for a specific or the cross-sectional area for this between two intervals, and we have also the mean velocity of that or in the middle of the two successive intervals. So we are going to put there in a table, for example in verticals 1 to 2, 2 to 3, until 10 to 11. So this is the value that we get earlier for cross-sectional area, so this is the answer for letter A questions. And the later the latter that we solve for the mean velocity is also here inputted. And we're going in solving the discharge, which is in cubic meter per second. We're going to use this formula. Discharge is equals to cross-sectional area times the mean velocity. So we're just going to multiply this one. For example, in verticals 1 to 2, so the cross-sectional area is 0.75 square meter times the mean velocity of 0.1. We have the discharge of 0.075 cubic meter per second. And for the 2 to 3 vertical, we have 2.7 na cross-section and mean velocity of 0.35. We have the discharge of 0.945 cubic meter per second. For verticals 3 to 4, we have the cross-sectional area of 3.9 and the mean velocity of 0.6. We have a discharge of 2.34 cubic meter per second. And for the verticals 4 to 5, we have the cross-section of 5.7 and mean velocity of 0.8. We have a discharge of 4.56 cubic meter per second. And for verticals 5 to 6, we have cross-section 7.5 and mean velocity of 0.9. We have a discharge of 6.75 cubic meter per second. And for the verticals between 6 to 7, we have cross-sectional area of 7.95 and mean velocity of 0.95. So we have the discharge of 7.5525. Vertical 7 to 8. So we have the cross-section of 7.8 and mean velocity of 1.05, which results into the discharge of 8.19 cubic meter per second. Verticals 8 to 9, we have cross-section area of 6.75 and 0.8 mean velocity. So we have a discharge of 5.7375 cubic meter per second. And the discharge, I mean the vertical 9 to 10, so we have a cross-section of 4.34 and a mean velocity of 0.4. We have a discharge of 1.74 cubic meter per second. And lastly, for verticals 10 to 11, we have a cross-section of 1.125 and a mean velocity of 0.1, which results a discharge of 0.1125. And to get the overall discharge of the stream at that specific range line, or specific location, we are going to get the sum of this discharge between the verticals, and the summation of these discharges leads to 38.0025 cubic meter per second. So this will now the answer for the question letter B. Alright. And to solve for mean velocity, which is the which was asked in the letter C question. So again, let's go back to this formula that discharge is equals to A times V. So we have now a total discharge calculated in the previous slide, which is 38.0025 cubic meter per second. And we have also a total cross-section area, which is 48.525 square meter. And the ask, or the one that was asked in the problem is the mean velocity at that specific range line, katong kung sa iyo yung pinaka mean na velocity. So we have a total discharge, we have a total cross section, so we are going to get now the mean velocity. So solving mathematically, or manipulated mathematically, so we can have a mean velocity of 0.7831530 139 meter per second, or let's say this is 0.783 meter per second. So this will now the answer for letter C na question sa ato ang sample problem. Alright, so much for the part 1 of this material. Let's go now, or let's move on to the part 2 of this material, which entitles the slope area method. So slope area method is used primarily of obtaining a peak flow of a stream after a stage has been receded. And the result of this method is obtained, or the result of this method is only for the approximation and are inferior in precision to those in which velocity is actually observed. Again, no, this is only for approximation. And the limitation of this method lie in the difficulty of selecting a correct value of roughness coefficient. So, kani siya nga method, if you are not familiar in the roughness coefficient, or this one, the n, so we have a table for this one, roughness coefficient. No, if ang lisod na part is to determine this one, no, the roughness coefficient n. But kung given siya, so dali na lang siya kaon. Pero kung ikaw mismo ang mukuha sa roughness coefficient, this diri nga part ang lisod. And also in measuring a flat slope with precision. Kung flat slope, wala kayo siya degree of rise, no? So maglisod ta og solve, no? Or to maglisod tag determine sa roughness coefficient. However, this method is useful in making rough estimates of flood discharge in stream and open channels. Okay, ang ato ramang kinahanglan kay ang slope sa specific area, which is makuha raman nato siya via bathymetric bathymetric na method, no? Or known na daan ang slope ang specific riverbed. So it's simpler, no, nga part para syempre kung magkuha pa kag discharge using another method, like for example the velocity area method, tapos bahaunon, no, nga lugar. So this method is really useful, no, in determining the estimation of flood discharge at the specific stream. And to obtain the mean velocity of the stream, we are going to use the cheesy formula, no? For open channels with Cutter's coefficient is generally used, and the cheesy formula is expressed as follows. So we have this formula, cheesy formula, which is velocity times c times the square root of r times s. And therefore, no, from the formula, discharge is equals to area times velocity. We're going to substitute the value of velocity for this one. So we can have discharge is equals to area times c times the square root of rs, where q is the discharge of the stream in cubic meter per second, and v for mean velocity, which is in meter per second, and a is for the cross-sectional area of the reach or the stream in square meter, and c for Cutter's variable coefficient, c, and the hydraulic mean depth for r, or hydraulic radius, no, in meters, and s for longitudinal slope of the water surface, that is meter per meter. And for Cutter's coefficient, to get the value of the variable c, no, so Cutter's coefficient is named also as, or denoted at c, no, is a variable coefficient whose value depends principally upon the roughness of the bed, no, and also upon the inclination, okay, since na siya slope, and also the hydraulic mean depth, or dr. So in practice, the value of c is commonly derived from the tables of diagrams based upon the formula of the Cutter and Gagula, which is expressed as c is equals to 1 over n plus 23 plus 0.0015155 over s all over 1 plus the quantity of n over square root of r times 23 plus 0.00155 over s, where cc is for the Cutter's variable coefficient, r is for the hydraulic mean depth or hydraulic radius, and for s is equals to, or it is for longitudinal no, slope of the water surface, and n for the roughness coefficient. So this is the crucial one. And to get, no, the another coefficient pala class is si Manning's coefficient. Manning's coefficient, so it is denoted as this formula, which is Manning's coefficient or Manning's variable coefficient is equal to r raised to the power of 1 over 6 over n, or the roughness coefficient, where r is the hydraulic mean depth or the hydraulic radius, and n is the roughness coefficient. And same formula for the to get the velocity is just c times the square root of r times s. And to get the discharge, i-times lang na to siya sa cross-sectional area. Alright, so another formula to get the velocity, no, di ba kaganina is no, using Manning coefficient, so v is equals to c times the square root of rs. So we can also have we can also use this formula, which is velocity is equals to hydraulic radius raised to the power of 2/3 times s, or which is the longitudinal slope, no, raised to the power of 1/2 all over n, or the roughness coefficient. Alright, so let's have a sample problem for this one. No. So given the following data of a stream of uniform flow, we have area is equal to 6.97 square meter, and we have P, which is the weighted parameter, no, weighted parameter to be perimeter rather. Again, area to be 6.95 square meter, and P, or the weighted perimeter, no, which is 9.76 meters, and S, or the longitudinal slope, to be 0.007, and given ang roughness coefficient to be 0.025. Assuming constant stream bed slope and little variation in the cross-section and condition of the bed, determine the following. First is the hydraulic radius. Hydraulic radius, and letter B for average velocity of the stream using the Cutter's coefficient, kung si C kaganina, and the corresponding discharge using those coefficient, and the average velocity of the stream using the Manning's equation or Manning's coefficient, and the corresponding discharge of those method. So this is the solution for the question asked for letter A, no, which is the hydraulic radius. So we have here the given area is 6.97 square meter, and weighted perimeter is 9.76 meter, and S for 0.0007, and N is 0.0025. So using the formula hydraulic radius, or the R, to be area all over weighted parameter, or perimeter rather, no, A over P. No. So substitute the value 6.97 square meter, and for P is 9.76. We have the hydraulic radius of 0.7141393443 meters. Again, wala na ako ni siya gi-round off, kay magamit pa nato ni siya later on. For letter B, no, na question, which is the average velocity and the corresponding discharge using the Cutter's coefficient. Again, we have here the given. No. So first is we need to determine the Cutter's coefficient, or the C, which is this formula, no, 1 over n plus 23 plus 0.00155 over S all over 1 plus the quantity of n over the square root of r times 23 plus 0.00155 all over s. Substitute the variable, no, the value for the specific variable, no. We have 1 over n is 0.025 plus 23 plus 0.00155, s to be 0.007 all over 1 plus the value for n is 0.025 all over the square root of r nga itong nakuha kaganina, which is equal to 0.7141393443 plus at times 23 plus 0.00155 over s nga 0.007. So we can have the value for C to be 37.47633.148 for C. The next one is to get the velocity. We have this formula, V is equals to C times the square root of Rs. Now, substitute the value for C is 37.47633,148 times the substitute the value of r to be 0.7141393443 times s to be 0.007. So we can have the value for velocity to be 2.649705,285 meter per second. And to determine its discharge, so using this formula, Q is equals to AV, or discharge is equals to area times velocity. So we have an area of 6.97 and the velocity of 2.649705,285 meter per second. So we can have a discharge of 18.46844,584 cubic meter per second. Or let's say 18.468 cubic meter per second. So this will down the answer for letter B. And for letter C, again, average velocity lang ipangita and the discharge, corresponding discharge, using again the Manning's coefficient. So this is the formula for Manning's coefficient, which is equal to C, or C is equals to R raised to the power of 1 over 6 all over N. So we have the value for R, which is the weighted perimeter, to be 0.7141393443 all over, or raised to 1 over 6 all over 0.025. So we can have the value for C using Manning's coefficient is 37.81729704. Now let's get the value for velocity, that is same lang gihapon. V is equals to C, which is the Manning's coefficient, times the square root of R times S. Substitute its values, no? V is equals to C, ang ato ang C is 37.81729,704 times the square root of 0.7141393443 times 0.007. So we can have the value for velocity to be 2.67381272 meter per second. And the corresponding discharge is again using this formula, Q is equals to AV. So substitute the value for A to be 6.97 and velocity to be 2.67381272. So we can have now the value for Q, or the discharge, to be 18.63647466 cubic meter per second, or let's say 18.636 cubic meter per second. So again, using the formula for velocity, atong pamaagi nga isa, so we have a formula atong dili bitaw, di ba, atong gigamit ring nga formula for velocity is equal C is times the square root of RS. So atong gamiton is katong using the Manning's coefficient to get the value for velocity, atong Manning's coefficient formula. So again, let's have C, which is the Manning's coefficient, no? R raised to the power of 1 over 6 over N. Substitute its values, it leads to C to be 37.81729704. So this formula that what I am talking about, no? Akong gi-discuss or akong gi-introduce sa ganina. So pagkuha sa velocity is equals to R raised to the power of 2/3 S raised to the power of 1/2 over N. Substitute its values for R, which is 0.7141393443 raised to the power of 2/3, and S to be 0.007 raised to the power of 1/2, and N to be 0.025. So we have a value of 2.67381272 meter per second. Same wala gyapon sa velocity ganina. And to get the discharge, same lang, kay same ang velocity. So we can also have the discharge to be 18.63647,466 cubic meter per second. Nganong naingani siya forma, no? nganong niabot siya ani nga nawong nga formula. So again, di ba balik ta adtong formula nga V is equals to C times the square root of RS, and CC is using this formula ato ang ibutang, or this is the Manning's coefficient, di ba? So C to be R is equals to 1 over 6 over N. Then we have RS, or ato ning tawag ani ato siyang inganing form, no? Square root is that is raised to the 1/2. So times RS raised to the power of 1/2, we can have this formula, no? Which is V is equals to R 2/3. Okay, i-add man na sila, di ba? Pag i-add, then CS is 1/2 all over N. Alright, so I guess this ends the presentation for topic 6 of this course. So for your questions and clarifications, again, you may contact me through our FB page and also in the LMS chat if you have clarifications, concerns, and you need guidance, no, in studying this topic. Alright, so thank you so much for listening and watching this video. I hope that it helps you in supplementing your learnings, no, in hydrography, even if it is online, no? So again, kung naglisod mo, again naglisod pod mi sa pag-deliver sa inyo ang kaninga subject and kaninga course. So laban lang ta, keep fighting, and mahuman na lagi ni ato ang pandemic na ato ang na hayaguman karon nga panahon, no? So again, thank you so much for watching and keep safe everyone.